Hello and welcome to this part of the tutorial. We started out talking in an earlier one about the difference between basically tree collections and hash collections, and noted that the real difference was that the trees had sorted order for its content, whereas hashes didn't. Now we're going to look at a particular kind of collection, a map, which of course has key value pairings, and we're going to examine just some aspects of that with the program that you may have seen in an earlier example. Here is the text or source code of this demonstration. We're looking of course at BlueJ, and I'm not really going to explain BlueJ, I'm just using it as an example for this example. Well, I'm going to talk you through this, hopefully just to settle the scene, or set the scene. The first thing to notice are the imports. Hashmap is imported here and TreeMap is imported here. The name of the class is MapDemo, and of course the constructor is here, and I've done all of my work really inside the constructor for convenience. And down here in the main method is an instantiation of this class. So we come back to the constructor. The first thing I do here is to set up a hash map. The generic type I'm using is integer and string. So I'm going to have a key which is an integer, which is an object. You have to have keys that are objects. And also the value is going to be of string, and again you have to have objects as values. So they're my pairing for key value pairing. It's quite common to have integers or numbers as indexes for arrays, but this is not an array, it's actually a map, but for convenience we're using numbers. As you'll see later on, it hopefully lends to a tutorial. So we're going to declare our instance variable map and instantiate it as a hash map here. Well, once we've instantiated it has memory, so we can actually load some data into it or put some values into the map. The first value we're putting in is 5, and the key for that is 5. We're putting it in because the method to actually add to this map is called put. The method to get from the map is also cunningly called get. So we're going to put, with a key of 5, the word 5, then the key of 8, the word 8, then 6, 6, 4, 4 and 2, 2. You get the idea, I'm sure. You notice these are not consecutive because they would be in an array, but they're non-contiguous is a technical term, because they're literally all over the place in what's called the heap in the memory, and not necessarily contiguous in memory as they would be in an array. Next we show an extraction. That is, we're going to get the value that is at the key 6, where it's going to bring back the word 6. When we say string text equals that, we're actually expecting the string text to actually have the value of 6. let's swing down to the bottom of here, and you'll see that we're going to actually use a tree map here, and that links in with what we were explaining a little bit earlier in another tutorial about the difference between tree map and an ordinary map or hash map. Anyway, more about that later. We'll come back up here. We said that when this runs we should get 6 SIX out into the standard output. Well, let's see if that's so. Now, to run this, I'm just going to click on there and say I want to run the void main. That will instantiate map demo, and we'll see the effect of running the constructor. And we see that 6 is indeed output. Now we keep this to hand because save, keep running the program, and go back to the tutorial walkthrough of this demonstration. Now here we have a loop, and the loop is commonly called a for each loop. It will go exhaustively through the entire collection. It won't stop until it has achieved a retrieval of all of the, or looking at all of the keys and the values. So we start with the first key, and the first key should be 5 and the value 5 as a word. We say we're going to get or extract the value into a string using the get method. Of course, we have to put key in as the argument. Because this is a loop, key is taking on the different values of the keys, in this case 5, 8, 6, 4 and 2, and this is facilitated by the key set method of map there. So that brings back all of the keys so that the keys can be sequentially referred to. Sequentially as in the sense of iteratively. In this line here we output the key value pairing. The key from here and the value, extracted value, from here. If we look at the solution, which we had, not the solution, sorry, the result of the execution, we can see we get 2, 4, 5, 6 and 8 as we expected. Next we're going to retrieve from the map. We've already done that, but we're going to do it again. So we're going to create an integer called key and say its value is 2. Then we're going to try and extract key value, a value using that key from the map. What we should get back is the word 2. And when we output this, we should get 2. And what we actually get is key 2 value 2. We can clear a map. We can get the size of a map. In this line here, we simply find the size of the map using the size method. Here we clear the map, which empties it out. And we can see the result of running those two methods, and here it is. Size of the map was 5, and then the size of the map is 0 because we cleared it. Well, next we're going to fill it again, which is just a copy and paste from earlier, because we want to have something in it for us to do something with it. We're going to use the contains key method. Very valuable. First of all, we simply output this statement: does hashmap contain 4 as key? Well, it either does or it doesn't. And here we use the map.contains key with a value of 4, because 4 is the key that we're testing for. Sorry about the pun. If it's successful, it returns true, and if it isn't, it returns false. The contains key method, I mean. Well, we'll have a look at the terminal output, and we see that it writes, does hashmap contain 4 as a key? True, it does. Well, it does. There it is there. Now the next question is, does it contain 4 as a value? And it comes out false. How come? Well, let's look at what happens. The question is 4 a value? Because we're not using contains key now, we're using contains value. Subtle difference. So this is querying the values in the map, whereas the previous method was querying the keys in the map. And I've just noted that this comment should say using contains key, and of course contain as a value. I'll just repair that as I go along. Now we saw that it doesn't, because there is no 4 as a value in this map. There are only numbers, integers for the keys, not for the values. So we're at this line here. What's going on? It asks the question, does hashmap contain 2 as a value? That is, the word 2. Well, we can see it jolly well does at key 2 there. So that should output true. And it does. So that's the use of contains key and contains value for querying the map, both extremely useful and powerful. Next, we're going to check to see if the map is empty or not. This is very straightforward. We're going to create a Boolean variable called isEmpty and assign to it the value of the isEmpty method of map. It isn't empty, so that should return false, and it does. Next, we remove some objects. What goes in must come out. So we say that before we do anything, map has certain values. Now this should be noted because it's quite useful that we can do this. Instead of using that loop, which we saw earlier, to go around a map and show us what's in it, we can actually just ask the system out print line to do it all for us. Thank you very much. So this line here is seen in the output as this line here. Hashmap before, and that's the list if I may call it that, shown in this format, which is the key value pairing. We're going to remove from the map the word 8. That is the value 8. And after we do that, we see that the hash map does not contain 8. So how did we do that? How did we delete it? Let's have a look. We create an integer. In this case, my key is equal to 8. I've used my key because key was originally declared earlier. I'm going to say object my value is equal to map remove my key. So the remove method, using the argument of my key, that's 8 here, will remove the word 8. This is object because we don't necessarily know what type this my value is going to be. In this case, of course, it's a string. So we say that the value is removed from the map here, and we say what the map is like afterwards here, which you've just seen. Well, thank you for making it to this point. We're nearly finished. We're going to use a sort now, but a sort probably like you didn't expect. We're going to put into this map at key 21 the word 21, then key 8, we're going to put 8 back in, 41, 41, 31, 31. Notice these are not in the order that I might have put in. They're not in a natural order at all. When we print this out, we see that it's not sorted. In order to sort it, all we need to do is to create a tree map. In this case, I'm going to call it a sorted hash map, which is a sort of very strange name for a variable, but hopefully in the context of this tutorial it makes sense. That we're going to have a sorted hash map, which is in fact a tree map. So we're going to say we're going to assign to this we're going to instantiate a new tree map. But notice what we're doing here. We're sending the map collection as an argument to the tree map constructor. Now what this will do is simply copy the hash map into the tree map, but it's not as simple. I said simply, that's probably not correct, because actually tree map is going to sort it all out for us. Because, as we said in an earlier tutorial, tree maps are sorted, we get a natural sort going on here. We don't have to use the collection sort method. It's just a case of bunging the hash map's values into the constructor for the tree map, and hey presto, it's all sorted for us. And finally we print out a confirmation of it being sorted. Let's see that in the terminal output. Now, just have to extend this, I think. So first of all, the unsorted hash map, as we expected, we've got 41 before 31 here, because that's the order we put them in. But here we've got a sorted hash map order where the keys are all in order or numeric order, because the tree map is doing that for us. Now it's true that the words, as it were, are also being sorted for us, but that's just coincidence, well, contrivance probably more accurately, because I've used the words to follow the keys, the values to follow the keys for this tutorial. But actually it's the keys which are being sorted. Well, I hope this tutorial has been useful to you and explained a few things, or just given you another way to look at how you can use the map.